Yeah, welcome to this team talk today. Analytics and monitoring, both are very broad fields, and when your software grows, they get more and more important. Now we want to accomplish that in a serverless way, so without operating like big clusters on our own. And that's what I want to show you today. So as you know, my name is Sebastian, and I'm here a software engineer at K15t. And just quick forward, so I might be talking a bit more about apps, but you can take apps as some sort of software as a service application, so just don't be confused if you read that in my talk. So what you usually do is when you start building your software is that you have some sort of containers, maybe you're using serverless functions, you have some database, etc. So you want to quickly get started with your software. And in the beginning, it's usually fine as long as the system is running, everything is good. And well, that's also good because then you can sell your software, and that's awesome. So your customers like it, they pay you, you can take the money and invest in something else, new features, etc. This is cool, but there are now also coming like some new obstacles, new opportunities, problems, etc. So you need to satisfy all the different people who are involved in that app. That could be like customers who love your product, they are asking for new features. That could be customers who say, oh, this is not working, please fix it for me. This could be like other developers, your own team, that say, okay, this doesn't work, we need to scale the system a bit more. But it could be also like the management team who says, oh, well, we have spent now 3 months on a certain feature, was that actually worth it? They want to know all those different things, and you need to help them somehow. So the question is, what can you do now in order to satisfy all those people? And there are 2 things here you can do. There are probably a lot more other things, but 2 things I want to talk about today, and these are like monitoring and providing some analytics. So just a quick poll, who of you is actually using AWS? Okay, great, yeah, most of you, okay, cool. So because like the things I'm talking about now is focused on AWS, so perfect fit for you. However, if you are using other cloud services, there's also a very good comparison site where you can see what the service is for other cloud providers. So if you're using Google or Microsoft, etc., then you see the companion service there, where you can look it up. Great, so let's start with the first part, with the monitoring part. And for that, as you might know, even the big companies, they are failing. And they have also big outages, like, for example, Google, Microsoft, AWS, all of them were affected at some point in time. But of course, like, you don't have the same resources as they do. So now let's just assume you're starting like with a small app. You could have some, for example, some sort of serverless architecture here, like lightweight thing. I'm having Jira here in this picture because like we're building apps for Jira, so that's just a reference. You can take it for any other app. So what you could do is, for example, you could do some webhook processing, you could have your own REST API, you're serving some front-end files, etc. If you want to know more about that, I also gave a talk about that, what are some best practices for serverless architecture, so you can watch it later. However, the main point what I want to bring here is that this architecture will fail at a certain point in time. And you just have to wait for that. And there are so many different things where your architecture can fail. So at this point here, I'm just, as you know, you're working in a network, unreliable network, anything can happen. Besides that, of course, also the different services can fail that you're using here. And and also, of course, your own services can fail that you're building. But the problem is here, you can't monitor all of them. But before I answer now, how we can monitor that, let's first see that we figure out what we should monitor here, because obviously you can't monitor all of that. If you have a look at AWS services, so they have more than 80 services which are automatically publishing some sort of metrics to CloudWatch. And that's quite a lot, but if you now take a look at all the different metrics you have available, there are more than 750 metrics available in CloudWatch that you can observe or monitor. And wow, that's a really huge number. Just as an example here for AWS Lambda, so there are like, I'm presenting here like some 4 example metrics, which are invocations, errors, the duration of your function, and how often it had been throttled. But there are, I think in total there are 8 metrics for Lambda, and that's just the Lambda service, so there's a lot more to monitor. And the question is, like, how do you actually find now the best metrics you should monitor? I think this question should be better rephrased into something else, and that is, which features actually providing the greatest value to your app? So if you know like your product well enough, then this should be probably an easy question, because if you know the greatest feature of the app, then which is bringing the biggest value to your customer, that's probably the thing you want to monitor or want to focus on in the first place when you initiate your monitoring. So if we now take another look at this reference architecture here, if you now focus on these parts which you have control over, then you can reduce all of that which is already like kind of monitored also by the cloud provider and, for example, other services. So you should rather focus on the things you have under control here. And as an example, what I mean with some like focus area or focus metrics is, so we are having an app, it's called Backbone Issue Sync. So I just quickly give you an overview in case you don't know it. So we synchronize basically issue data between Jira systems. So then you can have like, you can work in one project, your partner can work in the other project, and as soon as someone changes something in one project, it's synchronized over to the other side. And for this synchronization process, for example, we want to know how often such a synchronization was successful or not, and also how long it took, because I mean, the customers don't really care if it takes like 2 or 3 seconds to synchronize something, but they do care if it takes like a minute or maybe even an hour, so that's what we want to avoid here. And to some extent also the response times of the HTTP requests, they are also important because they influence the other metric. So the question is now, since we somehow have a feeling of what we can monitor, now we're coming to the part how we actually monitor that. And the first and most important service is of course CloudWatch. I assume since you're all working with AWS, you know that service. So I just skip quickly over that. So you can collect some events, you can collect logs, you can have some metrics in there, and alarms. So this is basically the first service to go to in order to do some monitoring if you are on AWS. You can then use the standard metrics as I've presented to you before, like with the Lambda metrics. If they are already enough, that means that they are matching somehow the metrics you have defined before for your app. Then you could also use the standard metrics. However, if that's not enough, you can also provide your custom metrics. And for that, you can like provide your custom metric here. You can use the AWS CloudWatch SDK. You define your metric data here, and then you just simply send it over to the CloudWatch service. And then there's some like nice feature basically. You can then push that or show that into your custom dashboard on AWS. And then you can also have dynamic metrics, so that you can calculate even more based on the metrics you already have and you're collecting. So you can have some, for example, mathematical expressions there. The only problem is now, if you establish that, what happens if you don't look at this dashboard? And I can assume that like it looks nice, but yeah, if you don't open that on a regular basis, you won't even notice that something is not working in the system. So what do? Of course, you configure some alarms. So CloudWatch has those CloudWatch alarms. You can send then an alert, for example, via SNS, and the developers or your operations team, they can just subscribe to that and get notified. And of course, an important part is also that you should probably put that into your infrastructure as code template. So you should also describe that and have it with you in your infrastructure, in your repository, so that everyone knows what type of alarms you have configured and you don't need to search through the AWS account. The follow-up question is now, well, great, I receive alarms, but what do we actually do now? And So that's like an important question here. You need to further investigate what's happening as soon as you get such an alarm. And one tool that can help you here is the X-ray tool, or the AWS X-ray. So X-ray is a service that can help you to investigate the HTTP traffic within your app. And since nowadays, like almost everything is using HTTP, this becomes a quite critical service you can to use. So what it does basically is, if you have, for example, a Lambda function and you enable the X-ray service for that Lambda function, you can see like the different HTTP calls you're making to the other services. And this is really useful, so because you can then investigate like how often were your HTTP requests successful, what, for example, average response time they had, and what type of responses you got. In order to do that, to use it now, you can simply enable that. So if you're using the AWS Lambda, or if you're using the CloudFormation SAM template, it's just like a small property you need to enable. And if you now, for example, use the AWS SDK, you can just add like a request handler and add this tracing handler, which then does everything automatically for you. So it sends those metrics to the X-ray service, and you don't have to care about anything. However, the problem might arise if you use some other services you're calling, and that is, for example, in our case, if we're calling something, if we're calling Jira, it gets a little bit more complicated. This is now just an example, so it's not that important to understand this code now. The important thing is that you can put this into your code and then monitor or measure your own HTTP request. And then you can, for example, you can use the X-ray service and then investigate the different traces you have collected. So I just made some like example of tracing here. You can see that there was like a successful response. It took almost took almost 600 milliseconds. And then you can see here all the different requests I've made and also how long those different requests took. And that's quite interesting. For example, if you have a look at DynamoDB, so they can respond within 80 milliseconds, which is extremely good. And then you see like there are some other requests like for Jira. If you need to call services outside of the AWS network, of course, this takes a lot longer because you need to get out of in the internet, etc. So you probably know how that works. And what you can now see here is you can easily see some bottlenecks in your application. So if you see, oh, my function's actually calling that, I don't know, 10 times, and it always takes 250 milliseconds, well, then you know why a function takes so much time to run. The only thing you need to be cautious here about is that you should keep an eye also on the pricing. So it costs you like $5 per 1 million traces, and well, if you have an app that does a lot of HTTP requests, you can reach those 1 million traces quite fast. There's some sort of like trick, maybe you want to apply it. You could potentially dynamically enable and disable it if you're using some environment variables with AWS Lambda. You could also use different things, but as an example here with the environment variables, as soon as you change that, you could then in your code, you could say, okay, if I'm using that, I build my AWS clients with the X-ray extension, with the tracing handler. Otherwise, I just build my client without that. So that's like a way to do that. And the other thing which I forgot to mention on the previous slide, so I mentioned something about the artifact size of your Lambda function. That's actually also quite important for those Lambda functions, because the bigger your artifact size grows, the slower is your cold start of those serverless functions. So that's something you want to keep in mind, because if you're using that, the Lambda functions, and you have, for example, as a REST API, and you expect like fast response times, then this might be not the best approach to just put dependencies over dependencies in your artifact, because that just slows down your serverless functions. All right, the next service that you can use in order to monitor your system is using AWS Lambda by itself. So as you know, you can run any kind of code in a Lambda function, and well, why not using it to monitor your system? It's actually pretty easy, so you can just define a CloudWatch rule, how you want to trigger your function, for example, based on certain events or on a certain schedule, and then you can run any kind of code. a simple example is here to check your own APIs, check if they respond with the expected result, and then if they don't do that, just send a notification to yourself using, for example, SNS or whatever you prefer. Then there is like another way. What you could do is you could also check this X-ray data that you are collecting just automatically. So there is an API in X-ray, it's called the Get Service Graph, and that provides you some statistics and some counts, which you can then somehow calculate how good your service is currently performing. And yeah, if you then do that on a regular basis, you can then call it and also send another notification to yourself. And then the last option is to also, of course, check your CloudWatch logs. So what you can do is, you can, for example, every time you enter some sort of log data into the CloudWatch service, you can then run a Lambda function to analyze that. You might now ask yourself, why would I want to do that? I could just simply handle that in my code somehow without logging something first. The reason why you want to do that, so just log something, log some data, and then analyze that afterwards, is that you then have an asynchronous call, of course, or asynchronous process here, so that you don't like slow down your actual business logic, so that can then continue to do something, and then as a separate function, as the separate Lambda function, that can then analyze what type of error you have, and then can clean up something, so you have a more loosely coupled system in the end. The only problem is here that by default you have like one log group per Lambda function. So you would have to listen to multiple log groups in the end, and that can make your whole solution a little bit more complex. However, what you could also do, instead of like listening to all those different log groups, there's also a rather new service. It's called CloudWatch Insight. Don't know who of you has heard about that before? Okay, so CloudWatch Insights is a service where you can then query your logs in the AWS console. So here's an example what you could do. You basically select the different sources, the log groups of that you want to search, and then you provide some sort of query what you want to search. For example, you could define the fields in the message, they provide some other default fields, then you can set a filter, for example, and then you can sort that based on the timestamp. And so it's the services then matching everything, and you see the results here at the bottom of your different log messages. And that can be quite helpful. For example, if you have some sort of like trace key of your messages, then you can see how the different events have been handled by your different Lambda functions. So we're using that actually quite often in our support cases. If someone says, hey, I have a problem with my issue XYZ, so it's not synchronizing, could you please double check that? And we can say, yep, that's fine. So maybe we need to ask some one or two other things, and then we have like a trace key which is handed over through all different Lambda functions, and then we can see how this event has been handled by the different functions. So that's really helpful. And then another thing is also the automatic JSON detection. So if you log some JSON data into the CloudWatch service, into the CloudWatch logs, you can also directly access that. So they have some automatic JSON support here, and then you can also filter based on certain fields in your JSON data. All right, that's already the part of the monitoring. So I'm talking quite fast because I want to match the 30 minutes. Are there any questions so far? Okay, good. Then I continue now with the analytics part. And so before we go into the details, just want to make sure that we understand that here. So for analytics, there are a lot of different tools available. So web analytics, like whatever you want to choose, there are thousands of tools. What I want to focus on here is on the data analytics part. So with data analytics, I mean I want to analyze the data I have already stored somewhere in my app. And somewhere can mean that I have different data stores available. And that could be, for example, a DynamoDB table. I could have something on RDS, in Kinesis or S3 buckets, or maybe on some other systems that where maybe store some data, but they don't directly belong to my application or to my infrastructure. So, but before we now actually start analyzing our data, we should make sure that we know somehow what we're actually trying to answer here. And I have provided here some example questions that might be interesting for you in order to figure out what your app or what data you have actually stored. So, for example, a popular example is that what type of configuration data have I actually stored? So if you have a software where people can configure something, and you might want to see if a certain setting is actually used by your users, that might be an interesting question. Or if there are some errors occurring in your app, you also might want to find that out. For example, if you have a REST API and you want to know actually how often are the requests failing, then this might be something interesting. Or you want to identify some access patterns, or the last question is also maybe interesting regarding your pricing strategies. So that means, can you identify who's actually producing the biggest traffic in your app? Because you might want to charge your users based on the traffic they produce. So let's start maybe with the first question here. What we have, or what at least in our case, is that we have stored some data in DynamoDB where we have different settings and configurations available that our users have configured in our app. You might have a similar situation that you store such data in DynamoDB. So a naive approach now would be, in order to figure out what type of configuration data we have there, is to simply make a scan on that table and then somehow analyze the data you have stored there. Now you could use, for example, an EC2 instance here in order to scan the data, but then it's not really serverless. So we want to make it serverless now. An easy way would be now to just replace that EC2 instance with a Lambda function. That maybe sounds easy and looks a little bit better now because now you have a serverless solution. However, if you now take a look at the other side here, so first the scan operations, they cost a lot of time and money, and because of the time, your Lambda functions can actually time out. So you know they have certain limits, how long they can run, and you might reach that quite soon. And also you probably don't want to do that on your production database. So now we need another approach. The other approach would be that you do this in the other way around. So instead of calling DynamoDB, DynamoDB could call you. So DynamoDB offers some streams that you can listen to. So you could, for example, attach a Lambda function to it, and every time an update happens, the DynamoDB stream is kind of calling your Lambda function and then executes it. And so your Lambda function can then do some processing on those new events which have been added. The good thing is here, you don't have any negative impact, and it's serverless, but you only get a few database updates per function call, and that's probably not what you want, because you want to know all of the data you have here. But there is a better approach available. So you can still take that, and you can stream your data into your Lambda function on a continuous, they're continuously calling your Lambda function, and then you could push that data in some sort of big data cluster. You could use, for example, Redshift from Amazon. However, the problem is here that you now have to run your own pricey cluster. And since we want to have it in a serverless way, all of that is not really satisfying. But there is another solution to that problem. And that solution is actually called Amazon Athena. So who of you has heard about Athena? Okay, great. So then you learned something new today. So Athena is a service where you can query your data, and you only pay them for the queries that you're doing here. So what you could, so the data then lies in the S3 buckets. So, and I think that sounds very promising here. how it works in principle is that you have a source bucket that you define for Athena. Then you define a schema on that, and then you can run your queries. So instead of like that from usual like SQL databases where you first have to define a schema, then you have to add some data, and then it matches against that and lets you insert it or not. Here it's actually the other way around. So you first add your data, then you define the schema, and then you can run your queries. And it actually doesn't really care if you have a wrong format in your data, because in that case you might get some errors later when you query it. So that depends a bit like how you define your schema and how you then query your data. Okay, so how can we now make use of that? You basically have your Athena service, and you can query in S3 buckets. And now we have on the other side our DynamoDB table, where we have our actual data that we want to analyze. What we can do now is we can leverage the approach from before. So instead of like pushing the data from the Lambda function to Redshift, we just push it to our S3 bucket, and from there we can then, on this bucket, we can then run the queries on our data using Athena. And you can push any kind of data like CSV data or JSON data, but they also support some other formats, Parquet and etc. I'm not too much into that, but maybe some others of you are. However, what we now have in this approach is that we can actually answer the first question here, that how much, which configuration data you have. So so that's what we wanted to know initially. And now I have some example queries here how that could look like. So for example, what we did with our own data is we wanted to figure out which different, that's maybe a bad example. So for Jira, you have different issues, and the issues have different fields, and that fields, there's data, and in our app you can define which fields you want to synchronize between the different issues. So what we wanted to figure out, which fields are actually used by users in our app. And then in combination to that, we have some field mappings. So we have different ways how you can then format the data between the different fields, and then you can run your synchronization. And we also wanted to know which mappings are actually used by our users. But for example, a more, or maybe a better example would be also here, if you have some CloudFront logs, if you're using CloudFront, you could also run that, so you log the CloudFront logs to an S3 bucket, and then you can run some queries on that to figure out what different types of errors you have actually returned in your REST API, for example. And now with all this information, you are able now to answer not only the first question, but also the second question. So if you can make sure that you have this data somehow prepared in an S3 bucket, like the error data you have, then you can also query that data. And also the third one, so if you now can make use of the CloudFront logs, you can then also identify certain access patterns. So the remaining question is, can we also identify who is actually producing the biggest traffic within my app? And for that, it depends a bit also like how your architecture looks like in your app. So if you, like, for example, have some service which or maybe a user which makes some request to the REST API, you might easily kind of measure that who is doing all those requests. If you have some sort of event processing available, this makes it a little bit more complicated because you could have multiple producers and consumers. So to collect all of that makes it a little bit more complicated. What we, for example, have is actually this scenario here. So we are receiving webhooks from Jira, we push that into a Kinesis queue, and then we run some Lambda functions on it and process that data. So if you then have the different Lambda functions, they have maybe different instances which are processing that makes it a little bit more complicated. However, Kinesis can also help you here in order to analyze the data you have. So in principle, Kinesis is first, it's a streaming service to collect a huge amount of data and then process it. And you can attach multiple consumers to that stream, but then what should you do with that data if you want to analyze it? there's actually another service, and it's called Kinesis Data Analytics. So with Kinesis Data Analytics, you can run, again, SQL queries on your data, which is flowing through that stream. And you can then also make some queries based on like a time window. So you could say in the last hour, I want to know how much data I have received for this, and then group it by, for example, a certain tenant key or something like that. And what you can then do is you can forward that data, for example, to another service or Lambda function. And then, well, you can do a lot more things. You can then, for example, push it again to S3 buckets, and then you can run again some more queries on that using, for example, Athena. So you're kind of like closing the gap here, what you can do. So if you connect all the different dots and services. That looks or sounds maybe very promising. However, you should definitely keep an eye on the pricing here, because the Kinesis streams or the services are quite expensive. So you pay for this data analytics service at least $80 a month. So there's no way to get below that, except AWS is reducing their prices. Yeah, so keep that in mind. So I would only suggest to use something like that if you really have a big need for that to analyze the streaming data here. All right, so that was the part about analytics. And so just a quick conclusion to check if we have kind of like covered everything what I proposed to you in the beginning. So you remember we have those different people here, like screaming for features, and something is not working. And if we now double check if we have achieved that goal, it's, I would say yes, you can satisfy a lot of those stakeholders here. The one in the parentheses are like not indirectly affected by monitoring or analytics, but still you can provide a good value to your users. And the main takeaways are here: you can actually do your monitoring and analytics based on a serverless way. You get a lot of flexibility, but also a lot of complexity. So the only thing is that you are moving the complexity out of your code into your architecture, because you rely on different services, and it makes it a lot more complicated what you're actually doing. And that's why it's important to also describe your infrastructure as code, so that you have some sort of place where you can manage all the different services in your architecture. But the cool thing is, for the analytics part now, if you store your data in S3, you can then also attach some machine learning services to that, because they can read the data from S3 as well, and then you can even further extend your app and provide new capabilities. That's it from my serverless analytics and monitoring aspects. Thanks a lot for listening, and if you have any questions, just let me know, and if you want to join a great team, here's a great link you might want to follow. Okay, no questions? Good.
One question. In the last, I think it was the last, or almost the last slide you asked, you told about Kinesis Analytics service.
Mm-hmm.
So you're already processing, and you warned about the cost, so that's why I'm asking. You're already processing the events from that stream in a Lambda or in a server or whatever.
Yeah.
So why wouldn't you just push that data you're interested in from there into an event, into S3, for example?
Yeah. So what you have, if you're using, for example, the Lambda function with Kinesis, you have different streams and, different shards, and you have, if you attach one Lambda function to the stream, one instance gets attached to one shard of Kinesis. That means you definitely have different instances processing the data, and not like the events which are sent into Kinesis are distributed among those shards, so you never really can process all of that data. So one instance of a Lambda function only gets a part of the data which is sent to the stream. That's a rather technical explanation. You can of course do something then with those Lambda functions and analyze the traffic that requires a little bit more to set up and to develop. The service here with Kinesis is just like let's say an easier way to accomplish that, to not build your own solution. That's the only reason why I was proposing that here.
How much do we pay for analytics and monitoring? They don't need to ask that.
Not so much. Okay, cool. Then I think we can move on, or maybe a quick break, and then we can move on to the second talk. Thanks.